Look up at the night sky. It's a vast, seemingly endless expanse filled with countless stars. Each twinkling star is a distant sun, many of which are much larger and more powerful than our own. The light from those stars has traveled vast distances to reach our eyes, crossing the universe over millions or even billions of human years. Many of these stars have planets of their own, orbiting them in a delicate cosmic dance. However, of all these countless stars and planets, Earth remains the only planet with perfect conditions to sustain life. It is from this platform that we look up, peering back in time to see the universe as it once was long ago. What we find is a universe that appears incredibly old, a vast expanse of time stretching back nearly 14 billion years. Humanly speaking, that's a long time. Imagine all that had to transpire over such an unfathomable age. But how did we discover this number? And how can we measure something so immense? Astronomers and astrophysicists have calculated the universe's age based on multiple methods and observations. To take on such an ambitious endeavor, some assumptions are clearly needed. The first assumption is that the universe looks the same no matter where you view it from, since we can only see it from our own solar system, and two, we assume that the properties we observe have remained unchanged throughout the history of the universe. With that said, let's explore some of the methods we have used to determine this incredible number. Imagine you're in a dark forest. Suddenly you see a firefly lighting up in the distance. Since it takes time for you to register where the light came from, you actually end up seeing a twinkling where the firefly was when the light was produced, and not necessarily where it is right now. In this same way, we can follow the trails of light in the night sky that reveal to us the history of our universe. One way we learn more about the age of the cosmos is by studying distant galaxies. These galaxies act as time capsules holding secrets of the early universe. By observing them, we can understand how galaxies have been evolved over the eons. The Hubble Space Telescope has captured incredible images of these faraway galaxies since the 1990s. Today, with the addition of the James Webb Space Telescope, our understanding of the cosmos is expanding exponentially, revealing images that were previously unimaginable. These images show us what galaxies looked like once upon a time. By examining these snapshots, scientists can build a model of how galaxies have been formed and changed over time. One of the most fascinating properties of light is that its speed is constant. This might not matter for most things we see every day with our naked eye. However, when it comes to looking deep into space, it starts to add up. Light from distant galaxies takes time, sometimes millions to billions of human years to reach us. Therefore, we are essentially looking back in time, to see ancient galaxies as they appear long before our solar system was even formed. The shape, size, and color of galaxies can tell us how old they are. Spiral galaxies are often younger and more active, while elliptical galaxies tend to be older and more settled. Younger galaxies also tend to be smaller and bluer. This blue color indicates hot, active star formation, with new stars being born in these vibrant regions. In contrast, older galaxies are often larger and redder, signifying older, cooler stars, typical of galaxies that have exhausted their star-forming material. Another way to estimate the universe's age is to study the oldest stars. Curiously, the famous Methuselah star is the oldest known star and appears to be 14.5 billion years old, which makes it older than modern estimates of the universe itself. This paradox highlights how our understanding of cosmic time continues to evolve with new astronomical observations. Astronomers can determine the age of a star by analyzing its light and composition. For instance, some of the earliest stars contain almost no heavy elements like iron and carbon, since those were only formed later by exploding stars. Surprisingly, the universe is expanding. Even more surprising, galaxies aren't just moving away from each other, they're accelerating. Scientists have observed this expansion by studying the light from distant galaxies. As a galaxy moves away from us, its light waves get stretched longer, closer to the red spectrum of light. By measuring this redshift, astronomers can calculate the rate at which galaxies are moving away from each other. However, the exact cause of the universe's accelerated expansion remains unknown and is not fully explained by our current understanding of physics. Some scientists propose that an unseen force called dark energy is driving this expansion. Be as it may, by mathematically reversing this expansion, we can wind back the cosmic clock to discover a single, hot, dense point at the beginning. At the point of convergence, something truly majestic happened at the beginning of the universe. The strongest evidence for the estimate of the universe's age comes from the cosmic microwave background, or CMB. A faint afterglow of this explosive event, this radiation which fills the universe, is a relic from when the cosmos was estimated to be only 380,000 years old. It provides a snapshot of the oldest light in our universe when conditions were cool enough for the first time for atoms to form. It's like a baby picture of the universe, capturing the moment when the universe transitioned from an opaque plasma to a transparent cosmos. The CMB's properties, such as its temperature, match predictions about the early universe. Tiny fluctuations in this temperature map reveal the seeds of all current structures, including galaxies, clusters, and superclusters. These observations support a cosmological point of origin, known today as the Big Bang Theory, and place the current estimate of the universe's age at 13.8 billion human years. The precision of these measurements is a culmination of all the advancements in our observational technologies. However, our estimates rest on key assumptions, most notably that the speed of light and the rate of cosmic expansion have remained unchanged throughout the history of the universe. If these constants were in fact subject to variables or external forces at any point in time, our calculations would need significant revisions. While scientific understanding is always evolving, the current 13.8 billion-year-old universe estimate is based on multiple lines of evidence. To recap, these include the expansion rate of the universe, the distribution of galaxies, and the abundance of elements that formed in the early universe. So, when you look up at the night sky, remember, you're not just seeing stars, you are looking back in time. The universe's story is written in light, and every new discovery brings us closer to understanding the beginning of the universe. If you found this fascinating, give this video a like, subscribe for more deep dives into the awe-inspiring science of our world, and let's keep exploring our home in the universe. Till next time.